Next is IOT Access Technologies. So the iOS Access Technologies. So in this particular topic, which I am going to cover is about the IEEE standards. That is the 802.15.4, 5.4G, 190128, and 802.11AH, and low iron technology. Right? And these are the different access technologies that is we are going to use for the IoT. So in the previous section, which is going to discuss the criteria that help you in evaluating IoT constrained network technologies for proper design and operations. So this section is going to provide an overview of the main IoT access technologies. The technologies highlighted here are ones that are seen as having market and are mind shaped. Therefore, you should have basic familiarity with them as they are fundamental to many of the IoT conversations. So as I told, the IEEE standard 802.15 series is a fundamental wireless protocol for connecting the smart objects. One thing you have to remember that there are many more IoT technologies in the market today than we can discuss here. Okay, and this particular section is going to focus on ones that appear on the strongest foothold. For each of the IoT access technologies, what we are going to discuss today, a common information set is being provided, particularly in the following topics are addressed for each IoT access technologies. That is the standardization and alliances, physical layer, MAC layer, topology, security, and the competitive technologies. The standard alliance is via the standard bodies that maintain the protocols for the latest technologies like Internet of Things. Okay? And this physical layer, it is as we know that the name itself suggests physical, the wired or wireless methods and relevant frequencies. The MAC layer, consideration of the media access control, we call it as a MAC, is a media access control layer which bridges the physical layer with the data link control. The topology is supported by the technology, okay, and the security aspect of the technology. Because whatever we are going to do in the network, we must provide the security for the technology that we are using. The last is a competitive technologies, other technologies that are similar and may be suitable alternatives to the given technology. While having the familiarity with these protocols and their capabilities is recommended, you may find that much of the information about these technologies is better used as reference materials. When you encounter these protocols, you can use the ND summary of the important details. Let me take this IEEE 802.1.5.4. It is an older but fundamental wireless protocol for connecting the smart objects. Okay, and for low cost and low data rate device that are powered or run on batteries, it will not use the external power source. Whatever the inbuilt power it is going to be mounted, the same battery it is going to be used. That is why it is a low cost and low data rate. In addition to being low cost and offering reasonable battery life, this access technology enables easy installation using a compact protocol stack while remaining both simple and flexible. Several network communication stacks, including the deterministic ones and profiles, leverages or use this technology to address a wide range of IoT use cases in both the consumer and the business markets. This IEEE 802.15.4 is commonly found in the following types of deployments. This is where we are going to apply this IEEE 802.1.4 is the home and building automation. Okay, we are going to use for our home appliances and automotive networks, industrial wireless sensor networks, interactive toys and remote controls. So there are some criticisms of IEEE. This 802.1.4 often focus on its MAC reliability, unbounded latency, and susceptibility to interference and multi-path fail. The negatives around the reliability and latency often have to do with the collisions in multiple access audiences, that is CSMA or CA algorithms is an access method in which device listen to make sure other device are transmitting before starting its own transmission. In another device is transmitting a wait time occurs before listening occurs again. Therefore, interference and multi-path fading occur with IEEE 802.15.4 because it lacks a frequency hopping technique. Okay. So these next is 802.1.54G IEEE are targeted to utilities and smart cities deployment. And IEEE 1901.2A, which is a technology for connecting the smart object over a power lines, and IEEE 802.11H technology built on the well-known 802.11 Wi-Fi standards, that is specifically for smart objects. Low area, wide area network. Okay, a scalable technology designed for longer distances with a low power requirements in unlicensed spectrum. The NBA, IoT, and other AT variations, which are often the choice mobile service providers looking to connect the smart objects over long distances in a licensed spectrum. Okay. Now, next is the most of the forms of radio communications are affected by multi-path fading for varying degrees. Multi-path fading refers to multiple copies of the signal hitting the receiver at different points in time because of the different signal paths and reflections. The ability to change the frequencies can mitigate the effects of multi-path fading. The standardization and alliances, that is IEEE 802.1.4 or IEEE 802.15 task group 4 defines low data rate physical and MAC layer because of the disadvantages what we found in the specification for wireless personal area network. This standard has evolved the low data rates that need months or even years of the battery life. For more detailed information, you can visit the website of the relevant IEEE 802.154. Since 2003, the IEEE has published several iterations of IEEE standard specifications, each labeled with a publication year. For example, IEEE 802.15.4 is 2003 was published in 2003, and another is published in 2006, and the next version of the same is published in 2011 and 2015. So newer releases typically supersede older ones, integrate and add features or clarification to previous versions. While there is no alliance or promotion body for IEEE 802.15.4. Okay. So these physical layers, the wired or the wireless networks and relevant frequencies used, and MAC layer considerations are at the media access control layer, which bridge the physical layer and the data link control. Topology supported by the technology, security aspects of the technology, computing other technologies with a similar and more suitable alternative to the given technology. Now, if you take this IEEE 802.15.4, it is actually a low-cost, low data rate and wireless access technique. The fundamental of wireless access technology, and that the is powered or run on the batteries was commonly found in the deployments like home automation, automated network, congested wireless info networks, and interact with toys and remote control. And it is going to focus on its MAC reliability, unbounded latency, and susceptibility introducing a big way. So now the protocol stacks utilizing that the low data rate MAC, the physical and MAC layer wireless personal medium networks. This standard have low complexity wireless devices with low data rates with a good battery life. These typically 802.15.4 PHY and MAC layers are the foundations for several networking protocol stacks. So in the protocol stack utilizing this 802.15.4 or ZigBee, low it is a sixth generation low power wide personal area network, ZigBee IP, ISA 100.111a, wireless heart, thread, and so what will be their functionalities and we take one by one. The protocol is ZigBee. So this ZigBee promoted through the ZigBee alliances. ZigBee defines upper layer components, network through application as well as application profiles. Common profiles which include the building automation, home automation, and health. This ZigBee also defines device object functions such as a device role, device discovery, network join, and security. For more information on ZigBee, okay, you can visit the ZigBee website, right? So next is sixth generation low power wide personal area network with an IPv6 section adoption layer defined by IETF. As I told that IETF is responsible for IoT, all its IoT connecting networks, right? This low power sixth generation low power wide personal area network working group that describes how to transport the IPv6 package or IEEE 8.2.154 layers and RFC is documented as compression and IPv6 enhancements to cover up with the specific details of IEEE 8.2.154. So ZigBee IP, that is the ZigBee Internet Protocol, it is an evolution of the ZigBee protocol stack. It adopts the low power wide personal area adoption layer, IPv6 network layer, and the RPL routing protocol. In addition, it also offers the improvements to IP security. It is going to be the very important role in the protocol. So next is the ISA 100.1a 11a. It is developed by International Society of Automation (ISA). That is the reason why it is named given ISA 100.11a. Wireless system for industrial automation, process control, and related applications. It is based on IEEE that is developed in IEEE standard. It is developed in 2006 and specifications were published in 2010 and then as a IEC 62734. The network and transport layer are based on the IETF and then UDP standards. This wireless hub promoted by the next is the wireless hub. It is promoted by the HIRT Communication Foundation. Is a protocol stack that offers a time which is going to be synchronized, self-organizing, and self-healing mesh architecture leveraging the IEEE 8.2.15.4, which is developed in 2006 over 2.4 GHz frequency band. They are increasing the speed also. A good white paper on wireless hub can be found on this system engineering guidelines. So next will be the Next protocol which we are going to study is a thread which is constructed on the top of IETF, that is a low power wireless personal area network under IPv6. Thread is a protocol stack for secure and reliable mesh network to connect and control the products in the world. Specifications are defined and published by the thread group at this juncture. Because of its relatively long history compared to other ZigBee, is one of the most well-known protocols that is listed in this particular table. ZigBee has continued to evolve over a time, as evidenced by the release of ZigBee IP and representation of IEEE 802.1.4 can be leveraged at the PHY and MAC limits, independent of the protocol layer above for these reasons. Both ZigBee and ZigBee API are discussed in more detail. So, ZigBee, if we take a ZigBee as a solutions for aimed at smart object and sensors that are low bandwidth, interoperate and low power needs, sets the commands and messages types are called clusters. ZigBee is the most well-known meaningful automation for commercial, retail and home appliances and smart energy. Okay. And you can see this high-level ZigBee protocol stack, how it is going to be implemented, how that layers are going to be placed. Okay. So high-level ZigBee protocol, application profile, application support, network and security layer, MAC layer, and PHY layer. So IEEE 802.15.4, okay, base layer which contains the MAC and the media access control layer and the physical layer. And ZigBee platform stack will be having the application support, network and security layer. Okay. Then we'll have application. ZigBee as a vendor specification, we'll have application index profile. If you take a ZigBee, it is based on the idea of the ZigBee style network in the late 1990s. The first ZigBee as specification was ratified in the year 2004. Okay, I'm talking about the ZigBee. Shortly after the release of IEEE 802.15.4 specification, the previous year, that is in the 2003, while it is not released as a typical standard like RFC, ZigBee still had industry support from more than 100 countries upon its initial publications. This industry is going to support has grown to more than 400 companies that are the members of ZigBee alliances. Similar to the Wi-Fi Alliance, the ZigBee Alliance is an industry group formed to certify interoperability between the vendors and is committed to driving evolving ZigBee as an IoT solution for interconnecting smart objects. So next, the ZigBee solutions are aimed at the smart objects and sensors that are low bandwidth and low power needs. Its products, the complaint and certified by the ZigBee Alliance should interoperate even though different vendors may manufacture them. So this ZigBee has gone several revisions. In the 2006 revisions, such as the command and message types were introduced, and increased the number in 2007 for ZigBee cooperation to achieve the different functions for device such as metering, temperature, or lighting control. These sets of commands and message types are called clusters. Ultimately, these clusters from different functional domains or libraries from the building blocks of ZigBee application profiles. So vendors which are going to be implemented with a predefined ZigBee applications profiles like home automation, smart energy can ensure the interoperability between their products. The main area where ZigBee is the most well-known include the automation for commercial, retail and home applications and smart energy. In the industrial and commercial automation space, ZigBee-based devices can handle various functions from measuring temperature And Zigbee Smart Energy brings together a variety of interoperable products like smart meters and can even monitor and control the use of the delivered utilities such as electricity and water. These Zigbee products are controlled by the utility provider and can help coordinate usage between the homes and business and utility provider itself to provide more efficient operations. The traditional Zigbee stack, as mentioned in the diagram, okay, Zigbee utilizes the 802.15 IEEE standard. It is going to have the lower, it will have the physical and math layers, right? Okay. So whatever we discussed in the diagram, the Zigbee network and security efforts mechanism for network setup, configuration, routing and security communications, which is going to include the calculating the routing parts in what is often a change in topology. Discovering best numbers and managing the routing tables is during this time. So this Zigbee also uses aerodynamic distance vector, okay, in short we call AODV, routing across a mesh network. Interestingly, this routing algorithm does not send a message until a route is needed. Assuming that next stop for a route is not a routing table, it is going to the network node to broadcast a request for routing connection. This causes the burst routing related traffic. But after comparison of various responses, the path in which lowest number of hops is determined for the connection. This process is quite different from standard enterprise routing protocol, which basically learn an entire network topology in some manner and store a consolidated completed routing.